One number, measured in a patch of ocean 2,000 miles from the nearest city, just crossed a line that changes the weather for the entire planet. It reads plus 1.7 degrees, and it is still climbing. That number has a name. It is called El Niño, the most powerful recurring force in Earth's weather system. And after months of lying quiet, it has just switched on, faster than anyone expected, and with every forecast update pointing not down, but up. In the next hour, I am going to show you exactly what is happening beneath those waves, why the last two events like this cost the world trillions of dollars and killed a sixth of its coral reefs, and why scientists are more afraid of this one than of anything the sky has thrown at us in years. Stay with me all the way to the end, because the reason the models keep getting worse is the part almost no one is talking about. Tell me in the comments where you're watching from, and whether your winter usually floods or dries out, because it could matter more this year than usual. Subscribe so you catch the moment this thing peaks. Now, let's get into it. Something enormous just changed in the middle of the Pacific Ocean, and almost nobody noticed the moment it happened. There was no explosion. There was no flash across the sky, no warning siren, no red banner scrolling across the bottom of a news channel. There was only a number, quietly climbing, week after week, in a stretch of open water so far from land that you could sail for days in any direction and see nothing but horizon. And that number, rising in silence, may end up shaping the weather over your town, your country, and every continent on this planet for more than a year. For most of the spring of 2026, the tropical Pacific was doing nothing unusual. Scientists have a word for that condition. They call it neutral. It is the ocean at rest, neither leaning warm nor leaning cold, sitting in the middle of a cycle that has been turning for thousands of years. Just weeks ago, the official readings still described the Pacific as neutral, only barely warmer than average, the kind of reading that puts forecasters at ease and lets everyone move on to the next story. If you had asked most people what the ocean was doing in April, the honest answer would have been almost nothing at all. Then the numbers started to move, and they did not stop. By the middle of June, the key measurement that scientists use to take the ocean's temperature had climbed to roughly plus 1.7 degrees Celsius above normal. That may not sound like much. 1.7 degrees is less than the difference you would feel stepping from one room into another. But this is not the temperature of a room. This is the average temperature of an area of ocean larger than the United States. And to move that much water, that much warmer, takes an amount of energy the human mind is not built to picture. When that number crosses a line that scientists drew decades ago, a line set at just plus 0.5 degrees, it stops being weather and starts being something with a name. That name is El Niño. And in June of 2026, the agencies that watch the sky and the sea made it official. El Niño had formed. El Niño was strengthening, and El Niño was expected to grow through the coming winter. Here is where the story stops being routine and starts being the reason you are watching this. El Niño returns every few years. That part is normal. What is not normal is what the forecasts have been doing since it arrived. In most developing events, the predictions settle down as time goes on. The computer models start out uncertain, scattered, arguing with each other, and then, as more data comes in, they converge, they calm down, and the expected outcome usually drifts toward the milder end. That is the comforting pattern we have come to expect. That is not what is happening now. This time, with every update, the models have been pushing the forecast in the other direction. Higher, stronger, worse. The people whose job it is to predict this put the odds of El Niño emerging between May and July at around 82%. That prediction has already come true. They put the odds of it surviving all the way into the December through February peak at around 96%. And when they look at how strong it might get at that peak, a majority of their models, something like 13 out of 24, are now pointing toward what they call a very strong event, the most extreme category on the scale. Some of the guidance is flirting with territory that would put this event among the largest ever recorded, since reliable record keeping began in 1950. Read that again slowly. The instruments are not calming down as we get closer. They are getting louder. You have probably heard the term El Niño your whole life, tossed around on the news to explain a strange winter or a bad fire season, treated like background noise. I want you to set that casual version aside for the next hour, because it does not capture what this thing actually is. El Niño is not a storm you can watch on radar. It is not a hurricane with a name and a track and a landfall. It is something stranger and, in a way, far more powerful. It is a slow, ocean-wide rearrangement of heat that acts like a master switch wired into the entire atmosphere of the planet. And when it is thrown, it quietly changes the odds of drought and flood and fire and storm everywhere on Earth at the same time, for a year or more, all at once. That switch has just been thrown. The most powerful recurring force in Earth's weather system is waking up after a period of rest. It woke up faster than expected. And the machinery we built to measure it keeps flashing a bigger number every single time we check. So the question that hangs over everything else is simple and unsettling. If the forecast is still climbing now, months before this thing even reaches its peak, then how bad does it actually get? And what happens when a monster like this lands on a planet that is already the hottest it has ever been in recorded history? To answer that, we first have to understand exactly what is happening beneath those waves, because the mechanism itself is more astonishing than any conspiracy theory you have ever been told. To understand why one warm patch of ocean can reach across the entire planet, you have to understand the machine it sits inside, and that machine is one of the most elegant and terrifying systems in all of nature. Most of us were taught to think of the ocean as a passive thing, a giant tub of water that just sits there while the weather happens above it. That picture is wrong. The tropical Pacific is not a tub. It is an engine, a coupled loop of wind and water that feeds on itself. And El Niño is what happens when that engine slips a gear. Under normal conditions, the winds along the equator blow steadily from east to west. Sailors have known these winds for centuries and named them the trade winds because they once carried ships full of cargo across the sea. These winds do something quietly enormous. As they blow across the Pacific for thousands of miles, they drag the warm surface water of the ocean along with them, pushing it toward the west, toward Indonesia and the islands of the western Pacific. Over time, that dragging piles up a mountain of warm water on the far side of the ocean. Scientists call it the warm pool, and it is exactly what it sounds like. A region where the sun-warmed surface layer of the sea is unusually thick, unusually toasty, and stacked so high that sea level over there sits noticeably higher than it does on the other side of the ocean. Above that warm pile of water in the west, the air does what warm, moist air always does. It rises. It climbs into towering thunderstorms, releasing torrents of rain over Indonesia and the surrounding seas. And that rising air is the fuel for storms across half the world. Meanwhile, on the eastern side of the Pacific, off the coast of South America, the opposite is happening. As the trade winds drag surface water away from that coast, something has to replace it, and what rises up from below is cold water, hauled from the darkness far beneath the surface. This process is called upwelling, and it is why the waters off Peru and Ecuador are normally cold, gray, and bursting with fish. The cold water carries nutrients up from below, and the nutrients feed one of the most productive fishing grounds on the planet. Now, there is a hidden boundary in all of this that you need to picture, because it is the secret to the whole story. Beneath the surface of the ocean, there is a dividing line between the warm, sun-heated water on top and the frigid water far below. Scientists call this boundary the thermocline. Under normal conditions, because the trade winds have piled all that warm water in the west, the thermocline is pushed down low on the western side and rides up high and shallow on the eastern side. That shallow boundary in the east is what makes the cold upwelling possible. The cold water is sitting close to the surface, ready to be pulled up. Remember that tilted boundary, because when it flattens, the world changes. The whole overturning loop, the rising air in the west, the winds blowing back east high in the atmosphere. The sinking air in the east has a name. It is called the Walker Circulation, named after a British scientist, Sir Gilbert Walker, and it was tied to this ocean cycle by a researcher named Jacob Bjerknes back in 1969. Bjerknes figured out something that changed how we see the planet. He realized that the winds and the ocean are not two separate systems. They are one system, locked together, each one driving the other in a loop. The name itself carries a clue to how long people have been living with this force. The term El Niño comes from Spanish-speaking fishermen along the coast of Peru, who noticed generations ago that every few years a warm current would arrive around Christmas time and drive the fish away. They named it El Niño, meaning the little boy, a reference to the Christ child, because it tended to show up during the holiday season. The cold, opposite phase of the cycle later got the mirror name, La Niña, the little girl. And the full scientific name for the whole oscillation carries Walker's contribution too. Because before Bjerknes tied it all together, Walker had noticed a strange seesaw in air pressure across the Pacific. When the pressure was high over Tahiti in the Central Pacific, it was low over Darwin in Northern Australia, and when one rose, the other fell, like two ends of a giant atmospheric balance. He called it the Southern Oscillation, and today the entire phenomenon is formally known as the El Niño Southern Oscillation, a single name stitched together from a fisherman's holiday and a scientist's pressure charts. What those fishermen felt in their empty nets a century ago is the same force the satellites are watching climb right now. Here is what happens when El Niño takes hold. For reasons that can start as small as a burst of weakened wind, the trade winds slacken. They stop pushing as hard. And the moment they weaken, that enormous mountain of warm water piled up in the west is no longer being held in place. Like water sloshing back across a bathtub, when you stop pushing it, the warm pool begins to surge back eastward across the entire ocean basin. Sea level can drop on the western side and rise on the eastern side by close to a foot as this happens. The warm water floods east, and as it arrives off South America, it deepens the warm surface layer. It pushes that thermocline boundary down, and it shuts off the cold upwelling like a hand closing over a faucet. The cold water that normally rises can no longer reach the surface. The eastern Pacific goes warm. Now watch the feedback, because this is the part that should make the hair on your arms stand up. When the eastern Pacific warms, it weakens the trade winds even more. And weaker trade winds let even more warm water slide east, which warms the ocean even more, which weakens the winds even more. The system feeds on itself. Scientists call this the Bjerknes feedback, and it is why a tiny nudge in the wind can grow over weeks and months into an event that swallows an entire ocean. There is no villain pulling a lever here. There is only physics, a loop that amplifies itself, an engine that revs itself higher and higher once it starts to turn. That is what is happening in the Pacific right now, and that self-feeding loop is exactly why the forecasts keep climbing instead of settling. And when that warm water reaches the Central Pacific, it drags the world's heaviest rainfall along with it, thousands of miles from where it belongs. The thunderstorms that normally soak Indonesia now fire over the open Central Ocean instead. Because those tropical thunderstorms are the main engine that drives wind patterns across the entire globe, moving them thousands of miles, rewires the atmosphere far, far downstream. It bends the jet stream over North America. It shifts the monsoon over India and Africa. It changes where storms form and where they die. One warm patch of ocean, and the whole planet feels the tug. So if this is how El Niño normally works, you might be wondering what makes the version forming right now so different. And the answer is hiding in the subsurface, in a wave you cannot see. Every El Niño is dangerous, but they are not all the same. And the one building in the Pacific right now is showing the fingerprints of something unusually strong. To understand why forecasters are growing more worried rather than less, you have to look beneath the surface at a signal most people never hear about, a signal that acts like a fuse burning toward the future. Before a powerful El Niño announces itself at the surface, it almost always sends a warning from below. Deep under the western Pacific, a pulse of warm water begins to travel eastward, sliding along beneath the waves like a swell moving through the dark. Scientists call this a downwelling Kelvin wave. You cannot see it from a ship. You cannot feel it from a beach. But instruments floating in the ocean and satellites watching from space can track it. And when a large one is on the move, it is like watching a loaded truck rolling toward a cliff. That warm water is going to surface off South America in the weeks ahead, and when it does, it pours fuel on the fire. The size of the subsurface warm pulse feeding this event is one of the main reasons the forecasters have grown more confident that this is not going to be a small, wobbling, marginal El Niño. The fuel is already in the pipeline. You might reasonably ask how anyone can measure the temperature of an ocean this enormous with enough precision to catch a change of 1 or 2 degrees. The answer is one of the quiet triumphs of modern science. Strung across the tropical Pacific is an array of moored buoys, anchored to the seafloor and bristling with sensors, that has been taking the ocean's pulse for decades. Drifting through the deeper water are thousands of robotic floats that sink, measure the temperature and saltiness of the water column, then rise back to the surface to beam their readings to satellites overhead. And from space, other satellites measure the exact height of the sea surface, which tells scientists where the warm water is piling up, because warm water expands and stands taller. Together, these instruments give us a living, breathing picture of the ocean updated day after day, which is how we can say with confidence that the warm anomaly is not just real, but growing. It is also why forecasters trust this event more as summer goes on. There is a stubborn window in the spring, which scientists call the predictability barrier, when the ocean is in transition and the models struggle to see past it. We are now clear of that window. The barrier is behind us, and the fog that clouded the earliest forecasts has lifted to reveal something larger than many had hoped. Then there is the behavior of the forecast itself, which I keep returning to because it is genuinely unusual. Think about how weather prediction normally feels. A storm is coming, the early forecasts look scary, and then as the days pass, the models tend to relax. The track shifts, the worst case fades, and we all breathe a little easier. That relaxing is the normal rhythm of forecasting. What has been happening with this El Niño is the opposite rhythm. Each new run of the models has nudged the expected strength higher, not lower. The event went from a barely warm neutral reading in the spring to a strong category reading by the middle of June, a jump that happened fast and cleanly, which itself is a signal. A fast, organized transition like that suggests the ocean and the atmosphere have locked together tightly, that the Bjerknes feedback is running smoothly, and that this event has real momentum behind it. It is not sputtering. It is accelerating. The numbers that describe the peak are the part that stops forecasters in their tracks. The scale they use runs from weak, at the bottom, up through moderate, then strong, and finally to the top category, which they call very strong. defined as the ocean running 2 full degrees Celsius, or more above normal across that key monitoring region. Reaching very strong is rare. It has only happened a handful of times in the entire modern record. And yet, right now, a majority of the computer models are pointing at exactly that outcome for the coming autumn and winter, around 13 out of 24 of them projecting a very strong peak, with the odds of a very strong event during the heart of winter, sitting somewhere around 62 to 63%. The chance of the whole thing fizzling out into nothing before then is described as negligible. In plain language, the exits are closing. This train is committed to the track. Now, layer on the single most important piece of context in this entire story, the piece that makes 2026 genuinely different from every El Niño that came before it. A strong El Niño works by releasing an enormous pulse of heat that the ocean has been storing, dumping it up into the atmosphere. That is why El Niño years tend to be the hottest years on record. The ocean exhales, and the whole planet warms for a while. But here's the thing. The last time we saw an El Niño this strong, the planet was cooler than it is today. This time, the ocean is about to exhale all of that stored heat onto a world that is already at record warmth, already running hotter than at any point in the era of thermometers. It is like turning on a furnace in a room that is already sweltering. The event is not arriving on a blank page. It is arriving on top of a fever. Some scientists have started asking a question that they do not ask lightly, a question that sits at the edge of what we understand. They are wondering whether an El Niño this large, arriving on a climate already this warm, could do more than just spike the global temperature for a year. They are wondering whether it could help shove the climate system across thresholds that it does not easily slide back from, whether it could help lock in a hotter world rather than simply visit one for a season. Most researchers are careful here, and they should be. The direct warming from El Niño is real, but it is also temporary, and the long-term heating of the planet is driven by other forces entirely. But no one can point to a moment in history where an El Niño this strong met a baseline climate this warm, because it has never happened before. We are, in a very real sense, about to run an experiment that the Earth has never run. So this is why forecasters are not relaxing. The subsurface fuel is loaded. The feedback loop is humming. The models are climbing instead of falling. And the whole thing is landing on the warmest planet in the history of our measurements. Every instinct we have says a forecast should calm down as it comes into focus. This one keeps sharpening into something worse. And if you want to know what a monster of this size can actually do when it fully arrives, you do not have to guess, because it has happened before, twice, within living memory, and both times it left scars across the entire planet. We are not flying blind into this. Twice in the last 30 years, the Pacific produced an El Niño so powerful that scientists gave it a nickname, the Super El Niño, and both of those events are burned into the record as warnings. If you want to understand what the 2026 event could become, you look at 1997 and you look at 2015, because those are the only two modern events in the same class as the one now forming, and reading them is like reading the file on a storm before it makes landfall. Before those two, there was a third event that deserves a mention, because it is the reason we watch the Pacific as closely as we do. The El Niño of 1982 to 83 was one of the strongest of the 20th century, and it did something that changed science forever. It caught the experts almost completely by surprise. At the time, the network of ocean sensors we just described barely existed, and the warm event grew to monstrous size before many researchers even realized it was underway. By the time the world understood what was happening, the damage was already spreading across the globe, and scientists were left embarrassed and alarmed that a force this large could sneak up on them. Out of that failure came the modern monitoring system, the buoys and the floats and the satellite watch, built specifically so that we would never again be blindsided by the Pacific. So when you hear that the forecasts today keep climbing, remember that the whole reason we can even see this coming is that an El Niño once humiliated science by arriving unannounced. We built the alarm because we learned the hard way what it costs to sleep through one. The 1997 to 98 El Niño earned a title that stuck. People called it the El Niño of the century. It grew into one of the strongest events ever observed, and the fingerprints it left were spread across the whole globe. In South America, along the coast of Peru, the warm water shut down the cold upwelling that the fishing industry depends on, and torrential rains battered the land. In East Africa, the same rearranged rainfall brought devastating floods, and with those floods came disease. Standing water bred mosquitoes, and an outbreak of a fever called Rift Valley fever swept through the region, a chain that ran from a warm ocean thousands of miles away straight into human bodies. On the other side of the world, the pattern flipped the opposite way. Indonesia and Southeast Asia were plunged into drought. The forests dried out, and the wildfires that followed choked entire nations in smoke. And in California, the warm event steered storm after storm into the coast, triggering catastrophic flooding and landslides. That single event, according to later analysis, raised the average global temperature for that period by around 1.5 degrees Celsius in its immediate effect, and it helped make the following year one of the hottest anyone had measured up to that point. But the number that stays with me is a different one. The heat that El Niño pushed into the ocean surface was so intense that it is estimated to have killed roughly 16% of the world's coral reefs. 16%. Not damaged, killed. An underwater die-off on a scale that is hard to hold in your head, triggered by water that got too warm for too long. And when economists later added up the floods, the droughts, the fires, the crop failures, and the damage, the global cost of that one El Niño came to an estimated $2.1 trillion. Then, it happened again. The 2015 to 2016 El Niño rose up to match it, and in some ways to exceed it. That event coincided with global surface temperatures that shattered records by one of the largest margins ever seen, so large that the years around it redrew the charts. Indonesia burned again, with wildfires so severe that the smoke became an international emergency. Ethiopia and parts of the Caribbean fell into punishing drought. Powerful hurricanes spun up in the North Pacific, feeding on the unusually warm water. And in a quieter but deeply worrying sign, that El Niño coincided with the largest single-year jump in the amount of carbon dioxide in the atmosphere that had been measured up to that time, as stressed forests and drought struck landscapes struggled to absorb it. When the bill came due for that event, the estimated global cost was even higher than the last one, somewhere around $3.9 trillion. Sit with those two numbers together for a moment. $2.1 trillion, then $3.9 trillion. The cost did not just repeat. It grew. And it grew in part because the second event landed on a more crowded, more developed, more interconnected world. A world with more to lose. Now ask yourself the obvious question. If the 2026 event verifies the way the models are suggesting, it will land on a world that is more crowded still, more warmed still, more strained still than it was in 2015. The trend line in those costs is not pointing in a comforting direction. I want to be careful and honest here, because that is what this channel is for. El Niño does not directly cause every disaster that happens during an El Niño year. That is not how it works. El Niño loads the dice. It tilts the odds. It makes drought more likely in some places and flooding more likely in others. And then the ordinary chaos of weather plays out on top of that tilted table. Not every prediction from 97 or 15 will repeat in the same places in the same ways. The Pacific does not read from a script, but when you have two prior events of this exact class, and both of them raised global temperatures to record highs, killed coral on a massive scale, drove floods and droughts and fires across multiple continents, and cost the world trillions of dollars. You would be a fool to shrug at a third one that the models say could be just as strong or stronger. These two ghosts, 97 and 15, are the closest thing we have to a map of the road ahead. But a map of the past can only tell you so much, because there is one crucial way in which the road ahead is different from anything those two events ever traveled, and that difference could decide just how far the damage reaches. To see it, we have to stop looking backward and start looking at the year that is about to unfold. If the forecasts hold, the effects of this El Niño will not stay politely out at sea. They will come ashore into your winter, your water supply, your fire season, and possibly into the record books as the hottest year humanity has ever recorded. So let us walk through what a fully developed El Niño tends to do, not as a certainty, but as a loading of the dice that is already underway. Start with the coming winter across North America, because that is where an El Niño makes its presence felt most directly. When the tropical rainfall shifts into the central Pacific, it reshapes the jet stream, the river of fast wind high in the atmosphere that steers storms across the continent. During a strong El Niño, that jet stream tends to strengthen and dip across the southern United States, and it acts like a fire hose of storms aimed at the southern tier. The result is a tendency toward a wetter, stormier winter across the south and the southwest, with a raised risk of flooding in California and along the Gulf states. At the same time, the northern tier of the country, including the Pacific Northwest and the northern plains, tends to run warmer and drier than usual. If you live in the south, the story of this winter may be too much water. If you live in the north, it may be too little. There is a strange mercy hidden in the pattern, and then a catch inside the mercy. One of the classic effects of El Niño is that it tends to suppress the hurricane season in the Atlantic. The same shifting winds that soak the southern United States also increase the wind shear over the Atlantic, and wind shear tiers developing hurricanes apart before they can organize. So a strong El Niño often means a quieter Atlantic hurricane season, which sounds like good news. And to a point it is. But hold the relief, because that suppression only dampens the Atlantic. It does not switch it off, and dangerous storms still form in quiet years. And while the Atlantic calms, the eastern Pacific tends to go the other way, growing more active, spinning up storms that can threaten Mexico and push moisture into the southwestern United States. Nature does not hand out a free gift. It moves the risk from one pocket to another. Then, there is the wider world, where the same event writes very different stories in different places. On the far side of the Pacific, in Indonesia, in Australia, across parts of Southeast Asia, and reaching into the northern Amazon, El Niño tends to bring the opposite of what it brings to California. It brings drought. The rains that normally fall over those regions shift away with the warm water. The land dries, the rivers drop, and the fire risk climbs. These are the conditions that fed the terrible wildfire seasons of the two previous super events, and they are the conditions that put stress on crops and water supplies for hundreds of millions of people. When the rainfall belt of the entire tropics picks up and moves, someone gains water, and someone loses it, and the people who lose it are often the ones least able to absorb the blow. There is a human cost that hides inside these weather shifts, and it deserves to be named plainly. Historical El Niños have been linked, again and again, to outbreaks of disease. It is not mysterious or supernatural. When the rain moves, the mosquitoes move with it, and diseases carried by mosquitoes and by contaminated water tend to surge in the places that suddenly get wetter, while other health crises follow the droughts. The Rift Valley fever outbreak in East Africa during the '97 event was one example, but the pattern shows up across the record, with cholera, with dengue, with a whole family of climate-sensitive illnesses. A warm patch of ocean, through a long chain of cause and effect, can end up changing the map of human sickness for a year. That is the reach of this thing. The reach extends onto your dinner table too, in ways most people never connect back to the Pacific. When El Niño shuts down the cold upwelling off South America, it does not just inconvenience local fishermen. The waters off Peru are home to one of the largest fisheries on the planet, and much of that catch is turned into fish meal, the protein-rich feed that fattens farmed fish, chickens, and pigs around the world. When that fishery collapses during a strong El Niño, the shock ripples through global food prices, quietly raising the cost of feeding animals on farms thousands of miles away. Add to that the droughts that scorch croplands in Southeast Asia, Australia, and Africa, and the floods that drown fields in South America, and you begin to see how a single ocean event can nudge the price of coffee, of cocoa, of rice, of wheat, of the everyday things that fill a grocery cart. Economists who have studied the two previous super events found that the drag on the global economy stretched on for years after the ocean itself had cooled back down. The bill does not arrive all at once, and it does not arrive only in the places you would expect. It arrives slowly, in 100 small increases, in countries that never felt a drop of the rain or a day of the drought. And then there is the number that may define the whole event in the history books: the global temperature. Because the ocean stores heat and releases it slowly, the biggest jump in global temperature does not arrive at the same moment the Pacific peaks. It lags behind by several months, which means the full thermal punch of a winter peaking El Niño tends to land in the following year. That is why a number of climate scientists are already pointing at 2027 as a leading candidate to become the hottest year ever recorded. Hotter even than the records we are living through right now. If that happens, it will not be because El Niño alone made the planet hot. It will be because El Niño stacked its temporary pulse of heat on top of a baseline that human activity had already pushed to record highs, and the two together crossed a line neither would have crossed alone. So this is the year the dice are loaded. A wetter, stormier winter for the southern United States. Drought and fire risk for Indonesia and the Amazon. A quieter Atlantic, but a livelier Pacific. Shifting patterns of disease. Coral reefs facing another wave of killing heat. And a real chance that 2027 is crowned the hottest year in the history of our species. None of it is written in stone, but all of it is now more likely than it was 3 months ago, and the tilt keeps steepening. Which is exactly the point where a lot of people stop trusting the official story altogether, and start asking whether something else is going on out there, something we are not being told. Those questions deserve a real answer, not a dismissal, so let us go there next. Whenever a force this large and this invisible reaches across the planet, the official explanation is never the only explanation on offer. El Niño is a magnet for suspicion, and I understand why. It is unseeable. It is blamed for everything from your bad harvest to the hurricane that missed and the one that did not. And it is announced by government agencies using acronyms and charts that most people were never taught to read. So it is completely natural that a lot of folks look at all this and think, maybe this is not just the ocean. Maybe someone is doing this to us. Let us take those questions seriously, one at a time, because some of them contain a grain of something real, even when the theory itself falls apart. The first and most common claim is that El Niño is a cover story, a convenient label that agencies slap onto the effects of deliberate weather manipulation. The idea goes that programs to seed clouds, or facilities that beam energy into the upper atmosphere, or the contrails you see behind aircraft, are secretly steering the climate, and that El Niño is the mask they hide behind. I want to answer this not with mockery, but with a number, because the number settles it. The amount of energy involved in an El Niño is almost beyond comprehension. We are talking about redistributing the heat absorbed by an area of ocean larger than a continent, a quantity of energy many orders of magnitude greater than the total output of every weather modification program that has ever existed combined. Cloud seeding can coax a little extra rain out of a cloud that was already going to rain. It cannot pile a foot of warm water across an entire ocean basin. The scale simply does not compare. It is the difference between a person pushing a car and a person trying to push a mountain range. And the mechanism was described in scientific papers back in 1969, and it is watched today in the open by satellites, by ocean buoys, and by an army of robotic floats operated by dozens of countries that do not agree on much of anything. There is no room in that system for a secret hand. The second claim is subtler and, I will admit, more emotionally persuasive. It says the agencies can predict this. They know how bad it is going to be, and they are hiding the real severity from us. Here is the problem with that one. It is almost exactly backwards. The forecasts are not being hidden. They are published in the open, updated week after week, free for anyone to read. And the criticism from within the scientific community has not been that the official numbers are too scary. It has been that they may have been too cautious, too conservative, because the models keep having to revise upward to catch up with an event that is outrunning them. That is not the behavior of an institution suppressing bad news. That is the behavior of an institution that keeps getting caught off guard by how fast the ocean is moving. What looks like a cover-up is really just the ordinary, frustrating uncertainty of trying to predict a chaotic system months in advance. The data is on the table. The trouble is that not enough people know how to read it, and not enough people are being told to pay attention. The third belief ties El Niño to earthquakes and volcanoes. The idea that when the Pacific warms, the ground itself starts to shake, and the mountains start to burn. This one is worth addressing directly because it comes up constantly. There is no established physical mechanism by which a rearrangement of warm water at the ocean's surface reaches down through miles of solid rock to trigger the movement of tectonic plates. The energy that drives an earthquake is stored in the grinding of continents, and it dwarfs the energy that El Niño moves around in the thin skin of the ocean surface. When people notice earthquakes and eruptions during an El Niño year, what they are usually noticing is that a dramatic year makes everyone pay closer attention to the ordinary, constant background rumble of a geologically active planet. The quakes were always happening. The El Niño just turned up the spotlight. The fourth narrative is the biggest of all. The claim that a record El Niño is being engineered on purpose to justify some political or economic agenda, a manufactured crisis to force through policy. And here the answer is written in the rock and the coral. El Niño is not new, and it is not a modern invention. Scientists can read its cycle going back thousands of years, recorded in the growth bands of ancient corals and in the layers of sediment at the bottom of lakes and lagoons. Records that were laid down long before any government, any agency, any modern institution existed to manufacture anything. This cycle was turning when the pyramids were built. It was turning during the Ice Ages. To believe it is being engineered now, you have to explain how it was being engineered before recorded history began. There is a fifth angle worth naming, and it runs in the exact opposite direction from the others, which is what makes it interesting. Some people take the fact that El Niño is completely natural and use it as a weapon to argue that the warming of the planet is therefore nothing to worry about, just the ocean doing what it has always done. This one deserves the same honest treatment as the rest. And the honest answer is that both things are true at once, and they do not cancel out. El Niño is natural, ancient, and cyclical, and it will swing warm and then cold and then warm again, as it always has. But the baseline it swings around has been rising, pushed upward by forces that have nothing to do with the Pacific cycle. Picture a person jumping up and down on a floor. The jumping is El Niño and La Niña, natural and rhythmic. But if the entire floor is slowly being raised on a hydraulic lift, then each jump reaches a little higher than the last. Not because the jumping got stronger, but because the floor moved. That is why the natural cycle and the long-term warming are not rivals fighting over the same explanation. They are two different things happening at the same time, and it is precisely their combination, the ancient jump landing on the raised floor, that makes this particular event worth losing sleep over. But I promised you a grain of something real, and here it is, because it would be dishonest to pretend these theories come from nowhere. The reason they take hold is that they are wrapped around a legitimate frustration, and the frustration is justified. El Niño's effects genuinely are underestimated by the public. The official communication genuinely does lag behind the science, and the economic and human costs genuinely do get downplayed until after the disaster, when it is too late to prepare. The honest version of the suspicion is not that El Niño is fake or engineered. It is that we can see this coming months in advance. We have the data, we have the history, and we still, again and again, fail to get ready for it. That is the real scandal, and it does not require a secret conspiracy. It only requires the ordinary human habit of ignoring a slow-moving threat until it is standing on our doorstep. Which brings us to the hardest question of all, the one that no theory, official or otherwise, can answer yet. We have traced this thing from a quiet number in the middle of the ocean, down through the engine that drives it, back through the two monsters that came before, and forward into the year it is about to reshape. So now we arrive at the question that no scientist, no agency, and no theory can fully answer. The question that makes this event more than just another turn of an old cycle. What happens when the most powerful El Niño in a generation meets the hottest planet in the history of human measurement? Understand clearly what is not mysterious here. The mechanism is not a mystery. We have known since 1969 exactly how the winds and the water lock together to make this happen, and we watch it unfold in real time from space. The cycle is not a mystery. We can read it in coral and sediment going back thousands of years. Even the general shape of the year ahead is not really a mystery. We know the winter tends wet in the south, dry in the north, quieter in the Atlantic, drier over Indonesia. All of that is understood. The mystery is not how this works, or whether it is real. The mystery is how big it gets, and what it does when it lands where nothing like it has ever landed before. Because here's the truth that separates 2026 from 97 and from 15. Those two super El Niños, as violent as they were, arrived on a cooler planet. They raised the temperature to records, yes, but they started from a lower floor. The event forming now is climbing toward the same strength, or greater, and it is going to release all of that stored ocean heat onto a world that is already running hotter than at any point in the age of thermometers. We have 2 data points for what a super El Niño does. We have 0 data points for what a super El Niño does to a climate this warm. That blank space in our knowledge is the real reason to watch this closely, and it is the reason some scientists are asking, quietly and carefully, whether this could be more than a temporary spike. The provocative version of that question is whether an El Niño this large could help tip the climate system into a hotter state that it does not easily fall back out of, whether it could act not as a passing fever, but as a shove across a threshold. Most researchers hold that idea at arm's length, and they are right to be cautious, because El Niño's own heating is temporary, and the long-term warming of the planet is driven by other forces. The Pacific will swing back. It always has. But no one can say with confidence what the combination does. The temporary spike stacked on the permanent rise. because we have never observed it. We are, in the plainest possible terms, about to find out. The Earth is running an experiment for the first time, and we are all inside the test chamber. No control group exists. No second planet is standing by for comparison, and the results will be written not in a laboratory notebook, but in harvests and floods and fever seasons across the world we actually live in. That is what the instrument panel is really telling us when the number keeps climbing. It is not just measuring an ocean. It is measuring how far into unfamiliar territory we are about to travel. Every forecast update that pushes the peak higher is a small signal that we are heading somewhere the record book has no page for. And unlike a hurricane, which announces itself with wind and rain and gives you the mercy of a clear moment of impact, this event will arrive without a single dramatic instant. It will arrive as a wet winter here, a drought there, a coral die off you will never see, a fever season in a country far away, a global temperature number quietly ticking upward through the following year. The most powerful weather force on Earth does its work in silence, and that silence is exactly what makes it so easy to ignore. So I will leave you with the thought that has been sitting with me since I started pulling these numbers together. The frightening thing about this El Niño is not that it is a surprise. It is the opposite. It is that we can see it coming with more clarity than almost any other natural threat on the planet. We can watch the warm wave moving beneath the surface. We can read the forecasts climbing week after week. We have the history of what events like this have done, written in trillions of dollars, and in dead reefs, and in floods and fires across every continent. We are being handed a warning months in advance, in broad daylight, with the receipts attached. The real question is not whether the ocean will do what it does. It has been doing it for thousands of years, and it is doing it again right now. The real question is whether, this time, with everything already stacked against us, we will finally do something with a warning we cannot claim we never received.